Hello, my dear students. So today we will discuss first topic, that is atomic number and atomic mass. Let's see that what is atomic number and atomic mass. Here I am writing atomic number, and here we have atomic mass. And we can understand that atomic number, that will be written as Z, and the atomic mass, that will be written as A. Alright, so whenever we consider any element, suppose we have any element like E, right, then the atomic number, that will be written downwards just like this, and the atomic mass, that will be written upward in this manner. So very important thing is this, that what exactly the atomic number is. So we can consider the atomic number in a neutral atom. Then we can go for number of electrons or number of protons. Clear? So number of electrons and number of protons, that will be written, in place of what atomic number. So this is the Z value. And as far as this atomic mass is concerned, atomic mass always be equal to number of protons plus number of neutrons. Here we can conclude that the Z value always be equal to number of, you can say, electrons or number of protons in a neutral element, or you can say atom. And as far as the mass is concerned, A will be written as number of protons plus number of neutrons. Here we have an example. Suppose an element hydrogen is here, right? And you know that the isotopes of hydrogen, we have three types: protium, deuterium and tritium. But in neural case, in the first one, hydrogen, where the atomic number is 1 and atomic mass is 1. So here we can conclude number of electrons, number of protons and number of neutrons in this manner. So number of electrons, that will be calculated from this side. Here we have 1. Alright. Number of protons, that will be concluded by this number as well. It's 1. And you know that the charge on electron, that will be minus, and the charge on proton, that will be plus. Overall charge is cancelled, that means that it's a neutral atom. And what about the neutron here? A neutron, that will be find out from this side. We have proton number, that is 1. So the atomic mass is always be number of neutron plus number of proton. So we can conclude that there is no presence of any neutron. So in case of H11, we have 0 neutrons, 1 proton and 1 electron. But in case of this, let's see, it's deuterium. In case of deuterium, you have to suppose find out number of electrons, number of protons, and number of neutrons. So number of electrons we can consider by this. So one electron we have, and of course one proton. But you see that there is a number 2. It means there is a one proton involved, but there is one neutron as well. So one neutron is also there. So in case of this deuterium, we have the atomic mass 1 plus 1, that means 2. That's why it is written as 2. Let's see one more example here. That is the tritium. 1, 3. Here we can say number of electrons, protons and neutrons. So electrons, protons and neutrons are number of electrons undoubtedly 1. Number of protons, no doubt, that is also 1. But what about the number of neutrons? And you know that this atomic mass is the sum of the neutrons and protons. So basically we have one proton, that means remaining are neutrons. So we have 2 neutrons here. So the atomic mass is 3. That will be easily written here. So these are the 3 examples. By using of these examples, we can consider number of electrons, protons and neutrons, and why not the Z value always be 1. But as far as the atomic mass is concerned, that will be different. Here we have 1, in deuterium it's 2, and in tritium it's 3. Well, let's see a few more examples to represent the number of electrons, protons and neutrons. Here we have the one example, that is H. It's 1, 1, and we have H1, but it is positively charged, right? And 1, 1, obviously it is negatively charged. So you have to find out number of, you can say, electrons, protons and neutrons. So each and every, you can say, ion or ionic species or atom having what different kind of, you can say, electron, protons, but proton number always be, same as far as the single atom is concerned, because it's hydrogen, right? So always protons are similar. So first of all, we have to find out number of electron in this. So we have 1, so we can go for 1. And number of protons, obviously it's 1. You know that the electrons are negatively charged, so we have 1 negative charge and 1 positive charge. But in case of the neutron, we don't have any neutron here, that means it's 0. Overall charge, 1 negative, 1 positive, obviously no charge, that means it's neutral. So we are not mentioning any kind of charge here. Let's see, in this case we have a number of electrons and protons and neutrons. Let's see. So basically you find that there is the mass which is 1, that means there is no neutron, right? Clear? As far as protons are concerned, then we can go for this. So 1 proton is there, it's positively charged. And what about the electron? In this case, what will be your answer? Well, basically you see that the 1 electron is removed from this hydrogen. That's why electron removed from its outermost shell, and there is no electron remaining. Alright, so basically 1 electron is out. So it means it is not having any kind of electron. So 0 electron is there. That's why the charge will be plus 1. Plus 1. So here we have to mention the charge, that is plus 1 or plus. I hope so it's clear to everyone. But in this case, the third one, you can say these are the hydride ions. So number of neutrons, no doubt we have one proton, but here you can see no neutrons. Number of proton, we can go for this 1. It is having positive charge. This particular electron, how can we find out the number of electrons? So basically you see that there is one electron, in case there is one electron, but one proton, that's why there is no charge. But you see that there is a negative charge. It means what? It means you have to include one more electron. Alright, so the number of electrons here 2. Now the charge will be, you have plus 1 and minus 2. So obviously it's minus 1. Clear? So in these examples we can consider the number of electrons, protons and neutrons. So there are a number of you can say atoms and ionic species where you easily calculate number of electrons, protons and neutrons. Okay, few examples you can try at home. Alright, if you find any kind of difficulty, you just pause the video and see the video from starting. Well, the next topic, that is isotopes. So isotopes, what exactly the isotopes are? Isotopes are those you can say elements or atoms which have same atomic number, but atomic masses are different. Alright, atomic masses are different. So we have taken one example of this isotope. We have already studied that we have 3 hydrogens, right? 1, 1, 1. We have 1 atomic mass here, it's 2 and it's 3. You see that that is the atomic number, the Z value remains same in all, right? But there is a variation in the number of, you can say, atomic mass. Alright, so these are the examples of what? Isotopes. So isotopes are those which have same atomic number but they have different atomic masses, right? We can conclude one more example here. Well, let's see that the example is, you know that suppose we have chlorine, right? Alright, so chlorine, it has 2 isotopes. The number is 17, right? But the mass is, here we have 35, here we have 37. So you can see that the number of you can say Z value, that will be same. The atomic number is same, but the atomic mass are quite different. So these are the examples of what? Isotopes. In next we have to study the isobars. Let's see that the isobars are, So isobars are those elements or atoms, those basically elements which have same atomic mass but different atomic numbers. It's been pretty easy, I think, and in previous classes you have already heard about it. So let's see that what the examples are. We have suppose argon, and other hand we have the calcium. The atomic number of argon is 18, but the number of atomic number in calcium, that is suppose it's 20, right? In argon the mass is 40, and in calcium the mass is 40 as well. Alright, so this will be the best example you can say. You can go for these examples to consider what isobars. So isobars are when the atomic masses are same but there is a difference in the atomic number, right? Can you find that number of electrons, protons and neutrons here? Okay, this is the work for you, and you have to find out the number of electrons, protons and neutrons in these two atoms. Well, we have the next topic, that is isotones. Well, you see that in isotones, those atoms which have same number of neutrons, right? They are isotones. Okay, this is the simple definition of isotones. Here we have one example. Let's see, the example is we have carbon, nitrogen and oxygen. The number of carbon is 6, nitrogen is 7 and oxygen is 8. Here the atomic mass is 14, here 15 and 16 in oxygen. So basically we can see that number of protons numbered, that will be 6, 7 and obviously 8. So we can write like this. And number of neutrons, well, let's see that the number of neutrons, basically we have 8 neutrons, right? So proton numbers are 6 plus 8, that will count what? 14. Obviously it's 14, right? And in nitrogen we have neutron number, it's also 8, and it will be the atomic mass 15. And what about in oxygen? We have 8 number of what? Neutrons. So overall the mass is 16. So we can say that these examples are showing that they have equal number of what? Neutrons. So they are isotones. Well, you see that there is the next topic, which is called the isoelectronic series. What it means? Actually, isoelectronic series, basically those elements, or you can say atoms, or ion or ionic species, okay, which have same number of electrons. All right, so this kind of, you can say, series is called isoelectronic series. We have a very simple example of it. Let's see that the example is here. We have carbon. We can take carbon, but another example I am just taking here. Let's see that what the example is. We have suppose oxygen. It's 2 negative. It's if negative. It is neon. Here we have the sodium and magnesium and aluminium, right? I'm just putting the charges here. Na plus, magnesium 2 plus, and aluminium 3 plus. We have to find out that number of electrons in these you can say elements and you can say ionic species. Well, let's see that. Here number of protons first of all, and then we go for number of electrons. Number of protons, you know that the number is it's 8, it's 9, it's 10, 11, it's 12, and it's 13, right? So proton numbers are 8, it's 9, 10, 11, 12, and 30, right? So proton numbers are mentioned here. Now let's see that the electrons number. You know that 2 electrons are added, that's why it is oxygen 2 negative, right? So it means in a neutral atom of oxygen we have 8 electrons, but 2 more electrons are gained. So basically 10 electrons are there, right? In case of this fluoride, there is 9 protons, and you see that in a neutral atom of fluorine we have 9 electrons as well. But you see that there is a negative charge. In negative charge we can consider the 10 electrons here. Well, in the next case we have the neon. There is no charge. That means what? The number of protons and the number of electrons are equal, so it will be 10. But as far as this Na plus is concerned, the 1 electron is removed from its outermost shell, so the electrons remain here 10. In case of magnesium, 2 electrons are removed, so basically the plus 2 charge is attained by the magnesium, so obviously the 10 electrons are also there. In case of aluminium, 3 electrons are removed from the outermost shell, so it will also consisting 10 electrons. So this particular series is the isoelectronic series because it consists same number of electrons. Well, for the further development of Bohr theory, there are a number of, you can say, theories we have to see. The very first one, that is the electromagnetic wave theory and electromagnetic radiation, right? So before we start this, we have to think about the wave theory first. Exactly what is wave and what is the wave theory? Well, let's see that. Basically हम यहाँ बात करें तो एक वेव को अगर कंसीडर करते हैं तो एक पर्टिकुलर डायरेक्शन जो है हमारे पास है ये वाला x, राइट? ये x आपकी डायरेक्शन हो गया. इस डायरेक्शन में कोई पार्टिकल जो है मूव कर कर जा रहा है, राइट? और वो अपना वेवी नेचर शो कर रहा है. इट मीन्स it is the particle here and it's moving in a particular direction in a straight way, so it shows its wavy form. तो कैसे wavy form को हम यहाँ शो करेंगे? आप इसको कुछ इस तरह से मेंशन कर सकते हैं. right? Like this. So basically this is the wave, right? So particle is located here, and it is having the kind of, you can say, energy, or you can say velocity. Velocity is suppose denoted by what? C, right? And this particle is moving in this particular x direction. So as far as the wave is concerned, that the wave is actually formed in this manner, right? Here you can see that these points, right? These points are called crust, right? And you see that the downward portion, these points are called trough. All right, they are trough. So basically crust and trough both are formed. It moves, you can say, upward like this, and it goes down like this. Here the distance between the two trough, here you can see that the distance between two trough or two crust, that is called lambda. That means the wavelength. Here lambda is called wavelength, right? आप ऐसा भी कह सकते हैं कि ये इसका ओरिजिन पॉइंट है, और ये पॉइंट, ये देखिए कंप्लीट हुआ एक क्रिस्ट, और ये आपके क्या बना, आपके ट्रफ, और ये कम बैक हुआ इस पॉइंट पर। ये जो आपके डिस्टेंस है, इसको भी आप क्या कह सकते हैं, लैम्डा, राइट? सो दिस इज ऑल्सो लैम्डा, दिस इज वेवलेंथ, राइट? अब एक बहुत इंपॉर्टेंट चीज आ रही है कि ये जो आपके ये क्रस्ट और ट्रफ जो बने हैं, राइट, इनका जो ये आपके पॉइंट है, ये जितना हाइट ये आपके जा रहे हैं, इसको बोलेंगे आप क्या? यस, इसको बोला जाएगा एम्पलीट्यूड, राइट? सो दीज आर द एम्पलीट्यूड्स, ऑलराइट? वन मोर थिंग, वेरी वेरी इंपॉर्टेंट, एक पर्टिकुलर पॉइंट आप कंसीडर कर लीजिए, उस पर्टिकुलर पॉइंट पर कितना साइकिल 1 सेकेंड में आपके पास हुआ, दैट मीन्स 1 सेकेंड में कितने अप डाउन्स हुए, उसको कहा जाएगा फ्रीक्वेंसी। क्लियर है? उसको क्या कहा जाएगा? फ्रीक्वेंसी। सो द पार्टिकल विच इज मूविंग इन अ पर्टिकुलर डायरेक्शन, राइट, it actually moves in a wavy form. So there are number of, you can say, crest and trough are formed. This is the amplitude of the wave, right? And you see that the distance between two trough or consecutive to trough, or you can say crest, that is called wavelength. And in a particular second, number of up downs is actually passing. So basically this is called frequency, right? So frequency, we have the velocity, right, and the wavelength. They have the correlation, and the correlation is this: nu equal to c upon lambda. All right, you have to keep in your mind. So what will be the relation between the frequency, velocity, or lambda? That means the wavelength. So that will be nu is equals to c upon lambda. So it's a very important, you can say, formula. Number of, you can say, question you can solve by using of this particular formula. Here one formula is also there, which has been called the nu bar. Nu bar equal to 1 upon lambda, right? So nu bar is wave number, right? Wave number, and the wave number nu bar is the reciprocal of what? Lambda, right? So it's very easy thing. but you must keep in your mind. Now the time comes to conclude that the electromagnetic wave, right? So basically, the Maxwell scientist has actually explained this electromagnetic wave theory in 1864. So what he said, let's see that. बेसिकली एनर्जी पार्टिकल जो हैं, जैसे इलेक्ट्रॉन हैं, प्रोटॉन्स हैं, या कुछ भी आप कहिए, जिनके पास एनर्जी है, राइट? और वो एनर्जी पार्टिकल जो होते हैं वो एक अगर पर्टिकुलर डायरेक्शन में अगर प्रोपगेट होते हैं या फिर मूव करते हैं, ठीक है, तो उनके वाई और जेड डायरेक्शन में इलेक्ट्रिकल फील्ड और मैग्नेटिक फील्ड जो होता है वो आपके डेवलप होता है, राइट? और ये तो हम अच्छे से जानते हैं। इलेक्ट्रोमैग्नेटिक आपके जो प्रॉपर्टी होती है व्हेनेवर द इलेक्ट्रॉन एक्चुअली मूव्स, ये हमने क्लास 10th में भी आपके स्टडी किया है फिजिक्स के अंदर। तो इसका एक छोटा सा एक डायग्राम देखते हैं कि किस तरह से क्या बोलते हैं इलेक्ट्रिकल फील्ड और मैग्नेटिक फील्ड जो होते हैं वो फॉर्म होते हैं। वेल, लेट्स सी दैट। हियर वी हैव the three-dimensional framework. Here the x direction, it's y, and it's z, right? You see that the particle, the energy particle is here, and this energy particle is electron, right? And this electron is moving in a particular direction, that is x. This is the propagation direction, your direction of propagation of electron, whatever. Here you can see that when the electron moves in a straight way, it creates, here you can see, suppose it's magnetic field, or you can say electrical field, whatever. Well, I'm just mentioning here like this. So suppose it's electrical field, suppose, right? So it's a E vector, or you can say E vector, that means the electrical field, right? So direction of propagation is x, in y, right, axis. Here the electrical field is developed. Meanwhile, whenever the electrical field is created, there is one more, you can say, field also there, that is this one, and this is the magnetic field, right, like this. Okay, so we can create this magnetic field in this manner. So both are perpendicular to each other. It means they are actually creating what, 90-degree angle. So basically this is the B vector, you can say, the magnetic field, right? So 3 axis, this is the direction of propagation of electron, right? And at y-axis there is a creation of what, electrical field, and meanwhile, and in the z direction we have the magnetic field in this manner, and both the fields, and they are perpendicular to each other. So this is the electromagnetic wave, right? But we have to see one thing, which is called the electromagnetic spectrum, which is also very, very important. Well, let's see that how can we make the diagram of it. So the next topic, that is the electromagnetic spectrum. चलिए आइए देखते हैं। कि इलेक्ट्रोमैग्नेटिक जो स्पेक्ट्रम होता है वो कैसा होता है, कुछ इस तरह से जैसे यहाँ हम शो कर रहे हैं। और इसका एक प्रॉपर स्लाइड भी है, वो भी आप देख सकते हैं। तो इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम जो होता है, स्पेक्ट्रम तो बेसिकली सब जानते हैं कि जब भी कोई वाइट लाइट जो होती है वो पास होती है प्रिज्म से, तो डिस्पर्जन होगा, तो बेसिकली 7 कलर्स हमें मिलते हैं, 7 विजिबल कलर्स विबगॉर हमें मिलते हैं। लेकिन अगर इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम के बारे में बात करें तो इसकी रेंज जो है हमारे पास में कुछ इस तरह से मौजूद है। लेट्स सी दैट द इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम। तो यहाँ जो हमको डिफरेंट जोन्स मिल रहे हैं, तो सबसे पहले हम बात करेंगे आपके विजिबल जोन की। तो ये जो आपकी जो जोन है, ये वाला जो जोन है पर्टिकुलर, इसको हम विजिबल जोन बोल रहे हैं। ये आपके जोन 400 आपके नैनोमीटर टू 700 नैनोमीटर के इन बिटवीन होगा ये, वायलेट टू व्हाट इन रेड, राइट? दिस इज द विजिबल जोन फॉर यू, इट्स मेंशनिंग हियर, राइट? विबगॉर। तो देखा जाए तो हम बोलते हैं कि भाई है ना, वॉयलेट जो कलर होता है उसका जो वेवलेंथ होता है वो क्या होता है, कम होता है, मगर फ्रीक्वेंसी जो होती है वो क्या होती है, ज़्यादा होती है। रेड कलर का जो है वेवलेंथ जो होती है वो क्या होती है, इसकी आपको ज़्यादा मिलेगी, लेकिन फ्रीक्वेंसी जो रेट है वो क्या मिलेगी, आपके कम मिलती है। तो डेंजर साइन हम रेड के बनाते हैं, क्यों बनाते हैं? क्योंकि इसका वेवलेंथ जो है आपके सबसे ज़्यादा होता है। ज़्यादा होने की वजह से ये दूर से हमें नज़र आ जाता है, राइट? सो ये पैच जो यहाँ पर है आपके, ये विजिबल जोन का है, वो ये है आपके पोर्शन। चलिए देखते हैं इसको इसके लेफ्ट राइट में, इस विजिबल जोन के लेफ्ट राइट में क्या है। तो सबसे पहले हम बात करते हैं इस विजिबल जोन के राइटवर्ड मूव करें तो हमारे पास आता है इंफ्रारेड, राइट? रेड के जस्ट बाद में इंफ्रारेड आगा। तो जितना भी अपने क्या बोलते हैं रिमोट्स वगैरह जो होते हैं वो इंफ्रारेड से ही चलते हैं, राइट? इसके बाद में आ जाती है माइक्रोवेव्स जो है, ठीक है? ये माइक्रोवेव्स भी आप अच्छे से समझते हैं। एफएम और एएम जो आपके वेव्स है वो अपने पास आ जाती हैं। फिर इसके बाद में लॉन्ग रेडियो वेव्स वगैरह ये सब चीज़ें आ जाती हैं। तो यहाँ जो है रेडियो वेव्स वगैरह ये सब चीज़ें जो हैं राइट वर्ड आपके आएंगी, क्लियर है? बट अगर हम देखें बहुत हाई इंटेंसिटी, बहुत ज़्यादा एनर्जी वाली, या फिर जिनकी फ्रीक्वेंसी बहुत ज़्यादा होती है, उन आपकी पर्टिकुलर जोन्स के लिए बात की जाए तो यहाँ अपने पास में जस्ट नेक्स्ट आता है यहाँ पर अल्ट्रा वायलेट जोन। अल्ट्रा वायलेट जोन, यू नो दैट इट्स वेरी हार्मफुल, राइट? और नो डाउट इनकी जो फ्रीक्वेंसी होती है हाई होती है। इसके जस्ट नेक्स्ट आता है, वो आता है अपने पास में एक्स रे जोन, ठीक है? तो ये जो जोन होता है एक्स रेज जो होता है, हाउ हार्मफुल इट इज, so we can understand. So it's a very high, you can say, frequency what rays। और एक्स रेज से पहले आता है अपने पास में जिसको बोलते हैं आपके गामा रेज, और गामा से पहले आता है आपके कॉस्मिक रेज। कुछ इस तरह से ये हम आपके इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम को जज कर सकते हैं, ऑलराइट? तो यहाँ मैं एक छोटा सा एक क्रिएशन आपको बताता हूँ, वो ये है कि अगर मैं यहाँ पर वेव को कंसीडर कर रहा हूँ, तो वेवलेंथ को कंसीडर करें तो देखिए यहाँ पर मैंने बहुत बहुत एम्पलीट्यूड्स भी इनके छोटे बनाए, और देखिए इनका जो वेवलेंथ है धीरे धीरे क्या हो रहा है, इंक्रीज हो रहा है, कुछ इस तरह से, राइट? जैसे जैसे ये क्या बोलते हैं आपके विजिबल जोन को क्रॉस करेंगी तो इनका जो वेवलेंथ है क्या होता जाएगा, बढ़ता जाएगा, कुछ इस तरह से। तो यहाँ ये राइट वर्ड अगर मूव करेंगे तो लैम्बडा का वैल्यू जो होगा हमेशा क्या होगा, इंक्रीज होगा, क्लियर है? लेकिन अगर फ्रीक्वेंसी की बात की जाए तो फ्रीक्वेंसी होती है न्यू। तो न्यू जो होता है वो वैल्यू इस आपके क्या बोलते हैं जोन के लिए सबसे ज्यादा होगा। तो यहाँ पर आपके न्यू यानी फ्रीक्वेंसी सबसे ज्यादा होगी इस जोन्स के अंदर, राइट? और फ्रीक्वेंसी लेस होगी यहाँ पर, क्लियर है? देख लीजिए 10⁻24 और यहाँ आ रहा है 10⁻2 हर्ट्ज में। लेकिन अगर यहाँ वेवलेंथ की बात की जाए तो वेवलेंथ जो होती है यहाँ पर देखिए बहुत कम मिलेगी, राइट? और यहाँ पर वेवलेंथ जो है बहुत ज्यादा मिलने वाली है। तो 10⁻−16 आ रहा है, देखिए 10⁻8 आ रहा है, ये विजिबल जोन आ गया आपके। यहाँ आगे 10⁻⁻6 आ गया, ये -2 आ गया, फिर देखिए इंक्रीज हो रही है 0, आपके 2, 4 एंड 8 एंड सो ऑन. So this is the electromagnetic spectrum for you. Okay, तो आई होप सो ये आपको क्लियर हो गए होंगे आपको टॉपिक्स. अगर ये टॉपिक में कुछ अगर थोड़ा बहुत कच्चा पक्का है तो आप प्लीज़ उसको रिवाइंड करें और एक बार दोबारा से क्या बोलते चेक कीजिए, इसको अच्छे से पढ़िएगा. ऑलराइट.